morning or good evening as the case may be, and thank you for joining this latest ClearEdge 3D webinar. I'm Chris Scotton, President and CEO of ClearEdge, and I got to say, we are really excited about this session because it's the first public unveiling of our new construction verification software called Verity. And apparently the industry is quite excited as well. We've got about 900 folks who have signed up for the session, making this probably the largest webinar we've ever done. So let's jump right in and talk about the agenda today. If you could advance the slide, please. Thank you. So we're going to do some introductions and talk about goals and context for why we developed Verity. And then Tim Malice at DPR will do a great case study on a project he used Verity on recently. And then Kelly Cohn, formerly of Beck Group, will talk about a case study they used Verity on, and then we will do a Verity demo and then open it up for QA. So just a few housekeeping rules. Everyone will be muted during the presentation. And we encourage you to ask questions, and you can ask questions via the chat window. And we will take most of the questions during the Q&A session at the end, but we may take one or two after each case study if it's relevant to the case study. And this webinar is being recorded, so you will receive a recording link to download or view it offline probably about a day after the webinar is finished. Okay. So introductions. Our first presenter is Tim Malice, who is project manager at DPR Construction. Tim, why don't you say hello and tell us a bit about yourself?
How's it going, guys? Like I said, Tim Malice, DPR. Been in the business for about 15 years, all sides of construction. Got into the management side about 10 years ago, and found out about laser scanning after a bad concrete sub poured a floor about 3/4 of an inch too high, and poured the next floor, started at 3/4 of an inch too low. And so ever since then I've been working to figure out how to use laser scanning to QA/QC items in the field. So this has been a passion of mine for last couple of years.
And Tim, I also have no acronyms behind my name, so you were in very good company, I have to say.
Well, LEAD is an acronym, right?
There you go. Our next presenter, you may know through his many speaking engagements and blogs. Kelly Cohn was the former director of VDC at Beck Group, and he liked ClearEdge and Verity so much he decided to join our team as a VP of Product Management. So Kelly, say hello.
Hello. So yeah, just a quick intro. I think Chris probably gave the cards away. I used to be with the Beck Group and spent about 10 years there. And one of the last things I was working on there was alpha and beta testing Verity with ClearEdge. We'd been a customer for about 5 years at Beck, and I had been very interested in trying to push this idea of laser scanning as a QA QC tool forward on our job sites, and had a really good case study, and then yeah, I ended up here.
And Kelly, now the idea for Verity, if you remember, came out of this hideously expensive dinner that I hosted about, I don't know, was it 2 years ago, and at AU in Vegas. And I think you were there, David Epps, Tom Greaves, Chris Lingiza, and a few other real great thought leaders. And I think we scoped the product on the back of a napkin amid some really good wine, and 2 years later, here we are.
Indeed it was.
Yeah, and I think as you'll see, Kevin Williams, who is our chief scientist, he and his team of just very smart people did a terrific job of taking those wine-soaked napkin notes and making them into just what we think is a really groundbreaking product. And as in all things, context is essential. So Kelly, why don't you lead us through a quick discussion on some of the market dynamics that are happening in construction QA, and then give a brief introduction to Verity before Tim jumps into his case study.
Absolutely. So one of the things that, of course, interested me long before we ever scoped this out on the back of a napkin was just how much money was really being lost in the industry as a result of mistakes in the field. And these are, honest mistakes. They're easy to happen out on a complex job site, but that doesn't mean they don't cost anything. And a lot of the different studies that industry institutions, that universities have done kind of point to this range of between 5 and 12% of a construction project's cost being spent on rework and the various different costs that accrue as a result of those field mistakes that cause rework. And so if you span that out across the entire construction industry and go with the low end of that number, that means about $450 billion every year goes towards rework and the associated costs. So that's not a small amount of money in our industry that's spent on this problem. And those of us that have spent time out on construction job sites are very familiar with the current way that we try and control quality, which is really a spot checking based workflow. So we go out, we use total stations or tape measures or laser measures, and we check to make sure that critical components, things we're concerned about, are in the right place. And there's a fair amount of crossing of fingers on everything else, and we just hope that if anything else is not in the right place, that it doesn't cause a big problem, because we really don't have time or money to go check everything, or at least we haven't in the past. But at the same time, reality capture within this industry has been growing. Tim and DPR, I know, have been working with it for several years. At Beck, they've been working with it for several years as well. And the prices keep coming down, and we're extremely excited about the BLK and the new Faro and some of the other scanners that are coming to market over the next 3 to 6 months that have basically shaved off the the price of entry into laser scanning almost an order of magnitude over the last 5 years.
But Kelly, I think one question is, how low will it go?
And that's a great question, and we're all sitting on the edge of our seats to see. But I think photogrammetry, some of these other low-cost mobile solutions are going to continue driving that down. It's going to be very interesting to see where the industry goes over the next couple of years. But I do suspect that we're going to see a proliferation of laser scanning, different forms of reality capture on job sites, just because it's getting to be so affordable and easy enough to use that you can really replace some of the other workflows that we've depended on for the last 50, 100 or longer years. But because of this, and I appreciate that Chris found a male model that had curly hair for this slide.
I thought that was you.
No. Little bit different. He's got more facial hair. Verity, we think Verity allows field engineers, project managers, and there are various people on the job site that are involved with the QA workflows to actually check 100% of the scope of work and do it really in the same amount of time that they're currently spot checking. I hope what Tim's going to show today and the case study that we've got from my time at Beck will help prove that point to all of you, because I think it really does make it achievable. And so with that, like Chris said, I'll give a very brief introduction into Verity and how it works. So fundamentally, the Verity product is integrated with Autodesk Navisworks, and so basically we see ourselves as a companion application. We see Verity working hand in hand with Navisworks, looking at two different sides of this QA puzzle. And the software compares design or fabrication models to terrestrial laser scan point clouds, and we're able to basically fit that to the point cloud and then do a couple of different things. So first, we will verify the presence or absence of those objects. So Our algorithms are able pretty reliably to determine between something that's not installed and something that's just occluded or covered up by other work that has been installed. We can certainly tell you if something is there and we found a good fit within the point cloud. So in terms of percent complete, we think, in 4D scheduling, we think this is a pretty powerful tool. And then the software will automatically flag what the algorithms see as out of tolerance work. And that's a tolerance that you type in, tell it what to look for. But we'll, based on that fit, we will tell you whether or not this is 1 inch, 2 inches, 3 inches out of tolerance, whether it's installed at an angle. So basically, give you that comparison between where it was supposed to be and where it actually is. And this algorithm works on pretty much anything from a software standpoint. So we don't care if it's a pipe or a beam or a complex surface. We're able to compare that back to the points that are adjacent to it. And we have the ability to update the physical location of that geometry in Nashville to the as-built position, which is we think going to be very helpful for trying to figure out if a mistake in installation is actually a problem. Because of course, not all mistakes are actually problems. And basically, on one hand, we've got the Verity application, which is really designed to help you interrogate that item, its relationship between its as designed and or to be fabricated and installed, and its as-built position. And then we have Navisworks on the other side, which really helps us understand contextually where that object is in the project and how it relates to other items. And with that, I think that's probably enough of a verbal intro. I think I'll turn it over here to Tim and let Tim talk a little bit about DPR and the project that they've been through recently.
And Kelly, you'll be doing a quick demo at the end of your presentation of Verity. And I would encourage folks to get your questions in now. We always have many, many more questions than we have time to answer them. So if you have a question, put it in the question box and we will do our best to answer.
Thanks, guys. Just quick about DPR. We're a general contractor based out of California, but we've got offices in Phoenix, Texas, Southeast. We've got Orlando, Tampa, West Palm Beach, Atlanta, and Raleigh, and then even up into the Northeast. So down the southern region of the United States. And we're expanding, and the $3 billion annual revenue number is the eye-catching one when we talk about 5 to 12% construction costs. Even that was one of the things that caught my eye, and knowing how much work we're putting in place on a yearly basis. Even if it's 1% that we can figure out how to quality control and catch prior to cover up. Even just 1% is $30 million of actual costs that we could save the company. So the DPR, one thing that's not on this slide is always voted one of the top best places to work in the nation. So with the likes of Google and Apple, so it's a heck of a company. And we actually use the Verity product on a composite job in Nashville, Tennessee. It's called Restoration Hardware, and it's a steel building with concrete poured in place. And as you can see here, we did some aerial photos, so we're also delving into doing some aerials and photogrammetry to also create point clouds and data from that. But for this particular application, they were interested in knowing what the steel was doing, because initially this project was put in place or created by another general contractor out of the ground. There's a basement to this building, and I'm not sure if the owner wasn't happy or it was just that was their time to turn over. I'm not quite sure on the details, but we did laser scan those embeds coming up out of the ground. And we did find problems. There was one complete embed that had to be that was missing, two that were completely out of place, and that was found with laser scans and Navisworks just doing visual check. The one thing that's interesting, and we can go into it later, but using Verity, about the same amount of time to go through the 583 steel items for the first, second, and third floor, about the same amount of time was spent using Verity to analyze all 583 steel items compared to the same amount of time that it took to analyze about 34, 35 embed locations. So right away, we're already starting to see power of being able to analyze a lot more and get a lot, use the data for, or analyze the data that we're getting from the laser scans. Yeah, next slide on this one. So the project challenges, a couple of items that they wanted to look at were slab edge locations, and then obviously the vertical and the horizontal steel. The vertical steel was dictated a lot by where those embed locations were, which I said before we had checked. But a couple of those items were twisted a little bit. We had a couple that we found to be off by a slight bit, but it wasn't enough that we felt like we could wallow out an embed plate to make the steel in place. But from the Verity results that we got, you could see some of the same problem areas were still problem areas. So, but they were concerned about exterior skin, slab edges affecting that, and the vertical and horizontal steel affecting the exterior skin. Field collection workflow for this particular project, it was 3 stories. We went around the outside of the building and then proceeded to scan interior, about 15 to 18 scans each floor, and then exterior. So it was a total of 73 scans. We are running a Trimble TX8 scanner. We're one of the only ones, our Southeast region is one of the only ones in DPR running the Trimble scanner. A lot of our guys are running Faro. And I know some of those guys are using Verity as well, so it's a little agnostic when it comes to, the program's a little agnostic when it comes to scanner types. Took about 5 hours. I think I started at noon and finished around 5 p.m. taking the data. And then one of the major challenges, and something we can talk about later, is just setting the benchmark. It is critical for Verity to be able to do its work to set proper benchmarks in the field. And we had a XY axis, but their Z axis was not obtainable on the day I was there, and it was a bit frustrating to actually run the software and find out that we were 2 inches in the wrong direction and then rerun the software. So, but Verity is good for that. Like we were able to actually analyze where the point cloud should have been based on the data that was presented in front of us. So for this particular project, I mean, the 73 scans, the workflow using Navisworks is exactly the same as the workflow that we used previously. We process it through RealWorks, and then we export to E57s and then bring it into Recap, Autodesk Recap. From there, we can use to dump it into Navisworks. So the same workflow applies, but then after we get everything aligned, it took about 3 hours to process all the 583 pieces of steel. And I guess what Kelly had mentioned to me before is like we see this product as something that you kind of set and forget, and you go to bed and you wake up the next morning and your results are ready. And that's exactly what happened here. Basically, 9 o'clock at night, get everything lined up, and then while I was sleeping, this thing was working. The computer was working, the Verity was working, and when I woke up the next morning, all the results were there, and I could go through. And this table of contents, it brings up a HTML report, and this HTML report brings up a table of contents, and every single item that you analyzed is available for further inspection. So on the slide here that you see under the host name, if you click on one of those items, it'll bring up that particular item, and we'll see that in the next slide in a couple seconds. But yeah, you click on that, and it will bring up the actual information on that with a top view, like 4 different views that for that particular piece of steel or whatever you're analyzing. 50% of the steel was installed out of tolerance. Now, we used a 1-inch tolerance on the steel, and when you're dealing with steel, 1 inch is a tight tolerance. In some cases, just you've got 20-foot I-beams. In some cases, there were 2 floors worth of I-beams, and so the 1 inch was a complete 1 inch out of tolerance. So like it takes into account everything, whether it be in the XY axis, Z axis, everything. So the 1 inch is a composite, or a composite of everything involved where that piece of steel is. So I wouldn't have done it any different, because it did flag some pretty far out of place pieces of steel in some of the areas, including one that was 3 inches, or actually a whole row that was 3 inches out of place. And you can see it going up the building. The more out of tolerance everything got. And on the next slide, you can actually see the results that came forward. So this is our first floor. As Kelly's slide stated before, the green states that it's within tolerance, yellow is out of tolerance, and the red is missing. The items you see at the top middle of the screen were missing for a reason. They weren't installed yet. The building is in a U shape, at least when we had laser scanned it, and that middle piece of steel was coming later. So it's good to see that the stuff that isn't supposed to show up in the report didn't show up in the report. And then we had gone through each item and basically did a screenshot of the overview and tag each item. So the hardest part of this job was to make a 3D report into a 2D report to hand to the guys in the field, be able to use the 2D report in the field, and be able to take it out with them, review the items, and say, yes, this is wrong, or no, this is okay because of this reason. A lot of the horizontal pieces of steel, they might have been out of tolerance by an inch and a quarter, but it's not a big deal as long as they're spaced properly. So all the horizontal steel going through, we were mainly focused on exterior pieces that might affect the skin. In particular, that item number 1 is an exterior piece that ended up being, I believe that was 2 inches too far to the planned north. So it will end up affecting their exterior skin. And as you can see, that same item for the second floor popped up out of tolerance as well. So basically, that same item number 14 that was number 1 before, it was the entire face of that area is out of tolerance. So I don't think there's much they can do with that particular piece, but they at least know about it, and they can make changes ahead of time to make it real, to make the problem go away, I guess, later on. But as you can see, the third floor, basically every piece of steel on the third floor was out of tolerance, and it's just as you go up. And if I would have done it again, I probably would have realigned a little bit just to see, is it out of tolerance for stuff that's happening on the first floor? Is it the stuff that's happening on the second floor? But the exterior face, that east exterior face of the building, had some issues, and a lot of it stemmed from a couple of items we'll see in future slides. But there were some angled pieces of steel that were meant to be installed on an angle for slope in an area that required some drainage, that got installed flat. So, and then the red pieces you see near items 23 and 24, those were just not installed, and the model called for it, and I put the onus on the field team because it looked like it might have been a double up on the architect's fault or engineer's fault or part. So that's the one key item to remember when you're using Verity. It's if the model's wrong, then you're going to get a false negative on your information as well. So it's imperative that you've got a virtual billing team that's staying up to date with the changes that are happening to make sure that any changes are making it to the model. So if you are going to analyze something, you really want to know you're analyzing against the correct information. So this is what I talked about when after you click on the HTML report and you've got your item list. And what I did is I went through every single piece. All 584 items, and I reviewed each one one by one and looked at it at the location in Navisworks and looked at the location in at least how far off it was, and identified if it was an actionable item or not. And so at the top left, you can see where it says action required. So that was something you're able to toggle in the system. So visually going through and looking at stuff, you can determine whether each is an actionable item or not. And then I basically ran an action item report that totaled the 45 items that we deemed to either need a further look from the field team or to fix in the field, really. But this particular item here was out of square and actually installed 2 inches too far to the plan north. And this is the one that we were talking about, I believe this is item number 1, yep. And yeah, this one is being looked hard at by the engineer and architect to make sure that they can come up with a fix to make up for the 2 inch difference. Another item that I wanted to talk about is item number 9, was on the second floor, and it's a piece of steel. It's a small piece of steel that, looking at it visually in Navisworks, it looks to be fine, but that was from 1,000 feet up, and kind of you're doing a quick overview. When you dig down into it and look at actually what Verity popped out, you can see that the piece of steel is not square to the building, and actually looking at it in the field, you can tell it's not square. So it did catch something that we would have missed visually, but the fact that we used the product here, and it gave us details on how far out of horizontal level it was, and how I think it had a 1 or 2 degree twist on the beam, and that twist, being able to sort your results by twist and rotation, actually really helps to narrow down on these pieces of steel that might be an issue for your exterior skin.
And I should kick in here, Tim, and say, if you don't recall from the earlier slide, in these views, the magenta, the purpley color one, is the intended location. That's where it's supposed to be installed. And the cyan, the bluish colored one, is where we fit that geometry to the point cloud, just to help people understand the color code.
Yeah, you can see from the different angles, the left 2 angles, it basically looks dead on. But then you really dive into it, and you see the actual number of results from the algorithm, or from the results, or the spreadsheet it kicks out. It really opens your eyes about being able to find stuff that you normally wouldn't find. And this one here was the piece of steel that we mentioned. There was a whole group of it, actually, that the model called for the steel to be angled, and the laser scan and everything in the field was installed. Or laser scan called it as a flat piece. It was installed as a flat piece, and yeah, that is one they're currently working on to fix right now. This was installed based on 2D drawings. They missed the fact that the 2D drawings showed the angle to be, or the steel to be angled down about I think 10 degrees or something, slight angle. But not only was it not angled, but it was installed at the wrong location. But I think they were more worried about getting that floor to be able to be sloped. So that is definitely something they're still working on. Because they found more. They did fix a floor's worth, and now they're up on the second and third floor fixing the same issue. So we did say that the issue was resolved within 1 day in the field, and it was, but they're currently working on some pieces to fix the other ones. And this one was particularly interesting. But yeah, after using Verity, I would definitely say that from the exact same project, using Navisworks by itself on 35 items, and then using Verity on the 583 steel items, and going through the same amount of time to go through a completely different, I mean, this was more than 15 times the amount of data that we were able to go through in the same amount of time. It's definitely a powerful tool, and we're excited about using it really further into the future. One item that is, I'm not sure if it's in the beta version right now that I know it's in the version we're using, but we're about to embark on using it. But there's a feature that basically you click on an item, you can click on a lot of items, and you can move the as-built, or move the model to the as-built position. Where that will be super helpful for us is we live in this perfect world of virtual building where everything is perfect. We coordinate to a perfect slab. We coordinate to perfect steel installations, and we're finding out more and more that it's not. We don't build a perfect world. So using the laser scanner and using Verity to basically laser scan and then go through and then shift everything that it identifies as being in the wrong position to the as-built position, we're able to take that information, rerun it into Navisworks, and then rerun our clash detection. So it gives that extra layer of knowing that before anybody shows up on the project, it's like, look, we coordinated, we spent all this money and time coordinating, and then you get out to the field and it's different. And that's one of the most frustrating things that I've seen as a project manager over the last 10 years. And finally, we've got a product and a solution with the laser scanner to go in and take that perfect world in the virtual building world and actually messy it up a little bit and do what and really verify and check against what's really going on out in the field. So that's something we're really excited about. I think we're testing that part this week on a project in Jacksonville. And then like I mentioned before, the workflow, it doesn't change for us. Like, yeah, it was just an extra 3 hours we used to analyze all those pieces. After lining up everything, it basically loaded up into Verity. Takes a little time, but then I think the 3 hours was just spent of the computer grinding away and comparing the laser scan information to the model information. So it's just one extra step. The workflow doesn't change, and it actually saves us time when you look at the grand scheme of things. Like if I would have had to go through all those pieces of steel, A, I would have missed a lot, and B, it would have taken me a lot longer.
All right, all right, Tim. Thank you very much. Yeah, with that,
now, we have had a number of questions come in, a couple that are relevant to Tim's presentation. So Tim, I got a quick question for you that came in. At your collection rate of 73 scans over 5 hours, what was your data tolerance level? 2 millimeters, 2 inches? The questioner asked, I guess, another way to say it is, what were your scanner settings, and then what is the optimal scanner settings for Verity?
So with the Trimble TX8, there's 3 options. There's a level 1, a level 2, and a level 3. The level 1 gets 500,000 points a second. The level 2 gets 1,000,000 points a second, and then I'm not sure what level 3 goes, but level 1 basically it rotates at 60 hertz, and it takes 1.5 minutes to do a rotation. And then level 2, it's like a 2.5 minute rotation. So you'll get an extra minute of scans for level 2. This particular one, I did a mix of level 1s and level 2s. Level 2s I tend to do in the middle of the floors where there aren't a lot of close by data. But the TX8 we're using is a little different. And we haven't sat down and actually looked at what the Faro comparison is on the between the TX8 and the different Faro things. I knew the new Faro that just came out is pretty quick as well. We didn't do color on this one, which allowed us to do a little quicker. The TX8 that I have actually does not have a camera embedded, but you can use a 360 photo or 360 camera or a fisheye lens with a DSLR, which is what we use. And actually, even when we do color scans, we're even a level 2 highly million points a second scan at 2 millimeters is our error rate. We're still getting 4 to 4.5 minutes of a scan location, so it is extremely quick. As for Verity, Verity does not take a lot. Like, they've actually told me to turn down the sampling rate when you're taking the E57 files out to recap. So, you know, the sampling rate at 2 gets you 1 every 4 points. Sometimes they tell me it goes far down to 6, 7, or 8. So you're an 8 gives you 1/64th the amount of size of your point cloud. But the way Verity works is it's looking for partial pieces of pipe or partial pieces of steel, whatever you're comparing against. And so with those partial pieces, it's still enough data for it to align it and match it to the model. So so we've had success with both level 1, level 2, and also just doing a much smaller point cloud size. Like the point cloud size I ran last night on a different project was, I think, a 2 gig size, which normally would have been 20 gigs. So it was a small, but we were able to run it through and got good data from it. So.
All right, Kelly, why don't you take it away?
All righty. And I do see a lot of other questions in there as well, but we'll save some of those for after this in the demo, because I think a lot of those will be answered in that part of the webinar. So I'm going to put my Beck hard hat on for a little while here. So if I say we in the next about 10 or 15 minutes, it's probably talking about Beck. I've only been away from there for about 5 months, so it's after 10 years, it still sticks. Beck is a great company. It's an integrated company, does architecture and construction. 7 offices. You can see all the stats up here, about $1 billion in annual revenue. And because of that integrated nature of the company, its virtual design and construction team is definitely focused on spanning that gap of communication between the design team and the construction team, and that led the company to jump on board the laser scanning bandwagon really early. It's been working with laser scan data for almost 10 years from now, and definitely had a lot of experience running Leica scanners and integrating that with design and construction models. So when ClearEdge came to Beck with the opportunity to start alpha testing and beta testing Verity, it was a pretty easy thing to jump on board with. Not to mention the prior conversation about a year before coming up with the idea with the whole team there. So we had a pretty easy project to start up with. We thought this would be a really good fit and would let us test out a bunch of different scopes. So we chose a central utility plant at a large hospital renovation somewhere in Texas, and basically ran through about 1,000 different elements through the course of this test to do a comparison, and that's looking at a number of different scopes of work that we'll dig into in just a minute here. And honestly, we didn't really expect to get actionable results out of a beta test. We don't typically deploy beta products on live projects, and this one was very, very close to closing out. So everything was pretty much buttoned up, we thought, on this job. And it was in many ways a challenging job. We were trying to break the software. So we picked a job with pretty dense MEP, lots of shadowing. We had a very short time on site because they were trying to close out the job. And we really only had a couple of days, maybe a week, to look at the data before the job really was going to issue final pay apps and just wrap up. And so we went into this thinking that it was just going to be a very academic test initially. This was about a 10,000 square foot central utility plant. Had 13 scans with our Leica P20. Took about 2.5 hours. And we had lots of activity on the site. You can see here 2 people that were standing right in the middle of where we were scanning, talking. We had people going in with materials, getting stuff cleaned out. So very, very noisy site from a capture standpoint.
Did you hit them with your Nerf gun?
No, I did not actually bring my Nerf gun that day. Yeah, that's a bit of a legend, the Nerf gun to keep people away from your scanners. That's a good pro tip, actually, for everybody listening. You just need to buy some Nerf guns when you're out scanning, and it keeps the construction workers away. So this is an overview of all the results. So similar to the image that Tim showed earlier. This is the colorization that we apply in Navisworks. So you'll see some occluded items here that were not visible in the laser scan. And I think we'd filtered out most of the not enough data items, but things where there's insufficient points or it's too far away from the scanner for us to make a confident guess, we'll exclude as well. But the key items here being the installed to tolerance, the out of tolerance items, and the missing items. So, looking at this more from the perspective of a person walking through the plant, you'll see here that there's quite a lot that's out of tolerance, and this has actually been a thread, a pretty consistent thread through our beta testing period over the last 3 months. People have been generally pretty surprised at how much is out of tolerance. I think we all within the industry have a suspicion that a lot of the work doesn't go in quite right. But since we don't really go out and measure everything, we don't really know how much. It's certainly been an eye-opener for me, and I know for a number of our beta testers, just experiencing how much of the work really is outside for various reasons of the specified tolerances that people are testing for. From a data processing standpoint, we ran through for the project. We ran through about 9 different scopes of work. It took about 10 to 15 minutes to process each scope of work. We had a very good advice early on to downsample our data set pretty heavily, which sped that up significantly. And then to QA it, just to review those results and kind of classify them, took us about 30 minutes per scope of work. And our overall findings, a number of the things in the cup were pretty well installed. Certainly a lot of out of tolerance, but overall followed the plans. And then there were a couple things that did not at all. And those were really the big surprises for us on this particular job. So take a look here at a couple of the ones that were more or less where they should be. So structure was pretty good overall. This was a masonry building, a CMU block, and then a steel structure for the roof. And for the most part, the work was installed about 2/3 within the 1-inch tolerance that we had specified for testing this particular work. All the items in yellow you can see were a little bit out. This job had a little bit of a shift to the northeast, basically. So the structure, and you'll see this with the steel as well, the structural walls and the structural steel were all shifted a little bit horizontally and vertically as we moved to the northeast of the building, which probably means there was a very slight control bust when everything was being laid out. But, we're talking about on the order of a 1/2 inch. And then the red walls in this case were just temporary walls that were put in differently than originally drawn. And in terms of what this looks like in Verity in the application, you can see here a heat map of that wall that we've got showing you how closely our as-built geometry fits to the point. So all the red points here are the conduit and different warts on the wall. And you'll see the overall results there in terms of what was checked. So this one took about 2 or 3 minutes to process. Steel, the structural steel was close, and you see we didn't scan the entire facility, just the primary mechanical cup. And we're doing really good on the southwest side of the building, and as we work up towards the northeast, you'll see we get more and more yellows, and that again is due to that control bus, which is about a half-inch vertical and about a half-inch northing and easting. But all of this, none of the steel was really something that raised eyebrows. It was obviously everything got built just fine. But it was interesting to know. And we did find a couple of members that had a little bit of deformation in them. Just this one was bowed a little bit. We found some with some twist just from reviewing each individual item and taking a look at it. HVAC was also pretty good. And it's worth making a point here that one of the fundamental premises of the software is that what you have modeled closely corresponds to what gets scanned in the field. And so Tim alluded to this a little bit. The duct was a pretty challenging thing on this job to analyze because the sheet metal was modeled, but this was all wrapped duct. So what was installed in the field was roughly 4 inches bigger in every direction with traditional duct wrap that was shiny and it sagged on the bottom. So in this case, the dimensional numbers that we reported out had some error in them as a result of that discrepancy. But we did find something interesting that over here on this side of the building, you'll see this ductwork that's flagged as missing. That piece of ductwork over there had to get moved because of an electrical panel that was misinstalled. But that was really the one part of the ductwork that we caught that needed a update to the as-builts. You can see here that heat mapping of the points against the duct insulation gives us a little bit of a challenge to work with. Fire sprinkler, so we're talking about 2-inch, 1-inch, black pipe that was scanned here, and while 66% of it was out of the 1-inch tolerance, all of it was within a couple of inches. We are actually pretty impressed how closely they followed their as-builts, given some of the other trades that got in before them. Again, you can see here the results out of Verity and the ability to take this purple geometry and fit it down to what's actually a pretty rough point cloud just because of the physical characteristics of the black pipe and how well that scans. And then the fun stuff. So obviously this is a central utility plant, and this was the mechanical room. So you would hope that the mechanical was prefabricated and installed per the drawings. And quite to our surprise, there were only 6 things that passed the test. Most of the large 6-inch and greater diameter pipe was within about a foot of where it was supposed to be, and the small was registered as not found in most cases. And this actually, we thought we'd broken the software when this first came up, and then we started looking at the results, and what we realized is that pretty much anything under 6 inches, they just field fabricated because this was their room and they weren't worried about anybody else's stuff. There were some interesting effects from this. You'll see the same kind of phenomenon with all the water piping that was put in. But the numbers are pretty crazy that, 110 items out of 296 were just not found because they were so far away we couldn't find anything in the point cloud that even remotely looked like the geometry. And then, like I said, water, same thing. It was actually a little bit worse. Nothing was actually installed close to where it was supposed to be.
Wait, what is that? What is that distance it looks for? Is it a foot?
In this case, yeah. So basically, we take about an 18-inch bounding box around where the object was supposed to be installed, and we'll try and fit the piece of geometry to whatever's within 18 inches of it in any given direction. So if it's outside of 18 inches, we're generally going to flag that as not being found. which is why we don't call it missing or not installed, because it could be installed just somewhere really far away from where it was supposed to be. But yeah, it was a pretty big eye opener for us. In particular, there were a couple of places where valves to basically turn off hot or cold water or turn off chilled water to parts of the hospital. Those valves were installed very differently than what was shown on the as-built drawings and in the coordination model. Of course, in a hospital, that's a life or death mistake. If somebody goes in and thinks they're doing regular maintenance on the 3rd floor and then turns off the water to the 5th floor where there's an operation, that's a big deal. And it was one of those things that the valves were in roughly the same configuration and arrangement. They just did different things. And Verity didn't tell us that, but by seeing that all the pipes that went into that rack of valves were actually different, we were able to get in and figure out that, no, actually the valve functions were different too. So like I said, we went into this not expecting to get a lot of actionable information out. Instead, we discovered that we needed to call the subcontractors out for these 2 scopes and basically have them redo their as-bills. Because otherwise what we were turning over to the owner was not a very good set of information for them to maintain and operate the building. We'd spot checked in this room, but we'd spot checked the 10 or 12-inch lines, and they were pretty close. It was good enough. But a lot of this other stuff really just surprised us. And as I say at the top there, obviously I must have been somewhat impressed because I ended up coming on board. So that's the project. Chris, did you have any questions you wanted to queue up before dropping into a quick demo?
No, let's jump into the demo. A bunch of questions have come through. We're getting short on time, so let's go right to the demo, and then we'll do as many questions as we can at the end.
All right. Well, I will be quick about it here. Let me get out of the slideshow and let's take a look at the product. So there we go. We'll unhide everything. So this is that central utility plant that I've got loaded up here. You'll see in Navisworks we have a structured point cloud, so that is one of the requirements. We right now do not work with photogrammetry or mobile data because we need to know where each scanner location is. So you'll see in our recap file here that we've got all the individual scan locations as their own RCS. That's what structured data means. That helps us do a lot of things on the algorithm side, so bear that in mind. And then you'll see, we've got the 2 data sets lined up. It's kind of hard to see given how far everything else is off, but fortunately we had control points on this job to use, and definitely would recommend that as the best workflow, is to leverage control points to locate your scan relative to the work that's installed, because that'll give you absolute results rather than relative results out of the package. But basically the way Verity works is that we go through and we pick objects that we want to take a look at. So I'm just going to pick a couple of different things here. And then we identify the scans that we want to analyze. And then we go to the Verity tab and we basically add those things to our Verity application. Now we've got the ability to run multiple different analyses per Navisworks file and per Verity project. So in this case, I'm going to create a new analysis to run through these various different things that I've identified and tested. And what we'll do is pull in that geometry. We give you some basic tools to help sort and decide if you really want to look at all that geometry. And then, once you're pretty confident you've got what you need to run an analysis, you'll go through this dialog here, set your tolerance, and typically we see people running a unique analysis per scope of work because not everything should be analyzed with a 1-inch tolerance. But you can set that. We've got a couple different options to help refine the analysis process, and then I click OK. But given that we're short on time, I don't want to spend the 5 minutes it takes to analyze this data. So instead, we will go look at one of the ones that we've already done, which contains most of these objects. So this analysis here ran in roughly 3 minutes. And what you'll see is we've got a list of about 10 items that were pushed through. And our application, after the analysis goes through, has broken out a bounding box of points around the object. We have tried to fit the intended location, the geometry, to the point clouds. And you'll see here we've got 2 different objects, right? We've got the purple one being that intended location where it was supposed to be installed, and this the cyan one that is where it was actually installed and fits the point cloud. Have a couple of different heat maps so you can see the points as they compare to the designed location versus compared to the as-built location. The as-built one will let you understand if there's some amount of deformation by the point coloring of the shape, so that would be things like camber or just sag. If either of those were present, you would see a gradation of color along here. We do not provide numerical results for camber or sag. Right now we're primarily focused on how the object is moved, and so you'll see here for this object we've got a lot of different measurements comparing those 2 pieces of geometry. So Tim mentioned rotation. So since we have 2 different pieces of geometry, and if it's the same piece of geometry, we can look at rotation and tell that this one's got a slight vertical rotation of about 1 degree, and everything else is pretty small on the rotation side. And then you'll see a lot of different translations. So we have some that are within the kind of frame of reference of the object, and then we have translation parameters relative to the project. So you can see within Navisworks coordinate system, are most of your objects shifted in the same direction on the X or the Y axis or vertically? And that'll tell you things like control buses, for instance. And then ultimately what we pull for this tolerance comparison is the total translation. So we'll look at the worst case point-to-point translation of the geometry to the geometry and compare that back to the tolerance, and basically tell you whether it was out of the tolerance, whether it passed, like this particular wall did right here, or whether it was uncertain. And so this is a great segue for making a general comment about any tool that uses algorithms. They are not always perfect. This is why we do emphasize that looking at the results is a critical step. Our software will never tell you if the problem is important and requires a fix, so you're going to need to look at them anyway. But B, there are scenarios in which the software is going to not have enough data or have some inconclusive data and may guess incorrectly. So in this case, it's telling us that it wasn't 100% sure what to do here, but as a person looking at this, I can tell that, in fact, we did a good job fitting this column. I can switch it to installed, and then it'll tell us this one is actually out of tolerance. And then we've got some connections back to Navisworks. So we'll take a look at one of these larger pipes up here that we started out with. You'll see when I select one in Verity, it's selected in Navisworks. So we can look at it, analyze it. We have the ability to push properties to Navisworks. So all these data fields that are in the table in Verity, you'll see those same data fields are now in Navisworks over here.
I was going to ask that if you push out properties in Navisworks and somebody doesn't have Verity on a computer, will those same properties show up when they open up Navisworks, or do they need to have Verity?
That's a great question. So yeah, the properties are in the NWF file. So if you send that NWF file and all of its source files to someone, or if you save it as an NWD and send it out, all of those properties will be there. And then Tim also mentioned we can shift that geometry. So if I push this button, what we'll see here in Navisworks now is that piece of insulation around the pipe is now moved down to match the point clouds. And while you certainly can clash point clouds in Navisworks, it can be a little bit challenging to work with and figure out the results. In this case, if you can just move the geometry to match, it gets much easier to understand what the impacts are of work that's been installed incorrectly. And so we can push those translations also. If you save to an NWD, those translations will be saved. And we're just using the Navisworks override tools for this, so it can always be undone, as you just saw, by just resetting the transform. You can even play ping pong if you really want to, just move it back and forth a couple times. Sorry, that was comedic relief. And then we've got a number of different reporting options. So Tim showed the HTML reports. There's also the CSV reports if you want to go do some data analytics in Excel. And then the last thing probably worth mentioning is being able to export the points for as-built. So if you knew you had a bunch of pipe that was installed wrong and that the right solution was to update the as-built files, we can actually go through, select all the objects that you want to, and we can export just the point clouds associated with those objects. So rather than sending the entire point cloud to a subcontractor or designer or engineer and saying, hey, you need to update your stuff, you can actually just send the points associated with the out of tolerance elements and colorized either with heat maps or with the colors from the host or a single color, which should help out a lot with the as-built side of the workflow. Just like the moving tool should help out a lot with the understanding the field impact side of the workflow. Chris, did I miss anything?
I think you covered it. We are running out of time. We've got a ton of questions. Now, we are not going to be able to answer too many questions, but we will email back and answer every question that was asked in the question window. So you will get an answer, but perhaps just not on this webinar since we are running out of time. And just to talk briefly about price, so Verity is sold on a single seat annual subscription. The MSRP is $5,995, same in euros and the same in pounds. And we have a launch discount for the next 2 months. We also have some multi-seat discounts as well. So, certainly if you're interested, contact sales at ClearEdge3D.com or your ClearEdge rep or your local dealer. We have dealers all over the world, and they will be selling Verity as well. We also have 21-day free trials available for select firms. So if you're interested in a trial, just put that in the chat window and send that to me, or send a request into sales at ClearEdge3D.com, and we will get you up on a free trial for 21 days. And it is not a dongle-based software. There's no dongle to go back and forth, thank goodness. So it's a software lock that manages that trial and manages the licensing. So let's go to questions, and we'll get as many done as we can in the short amount of time we've got. So Kelly, first question really was about the different platforms. Will there be other platforms other than Navisworks that Verity will integrate with? And then the following question, which Navisworks versions does it work with, and will it be available in 60 Glue?
Yes. So the short answer is that yes, there will be other platforms, but not for the immediate future. So we have a couple of additional integrations planned that will hopefully be popping up towards the end of the year, next year. But at least for the immediate future, we're focused on the Navisworks platform because it has all the coordination models in most of our markets, and that source of model data is pretty valuable for us, obviously. We work with Navisworks 2015 and 2016. We will, of course, be working to support 2017 once it officially comes out as quickly as we can. But right now focused on the 2015 and 2016 versions. And Chris, what was the last part of that question? I didn't quite catch it.
360 glue.
Ah, yes. So we do not currently support 360 glue, and that's because of the way that software handles point clouds. I would encourage people to reach out to their local Autodesk reps, their friends at the factory, and beg for them to support point clouds in their cloud-based applications, because that obviously is a prerequisite for comparing models to point clouds. Basically, they need to let their recap files show up on the cloud. I'm sure they're working on it, but we'd love to support it. It's just there's nothing to support right now.
So now being the commercial guy here, I'm going to ask you to define foreseeable future, because that's kind of an amorphous term. So what's your sense of when, do we know when the next platform will be supported?
So I'm going to reiterate and pull the product management answer and say we are planning on that being towards the Q3 or Q4 of this year for the next platform, and it will be there will be additional platforms announced over the next couple months as we really iron out our plans.
Perfect. Okay, great. Next question. So how does Verity compensate for high gloss steel piping and ducting?
So the way our algorithms work, without getting too deep or giving away too much of the ingredients of the special sauce, we're basically fitting geometry to points that we find around the object and looking for what the best match is. So you may have noticed on the analysis tab there's a checkbox for indoor scanning. We have that checkbox because if you're outside and there's holes in your data, it's probably because the sky is there. If you're inside and there's holes in the data, it's probably because there's a highly reflective material or a very dark, rough material, something that does not reflect laser light very well. So, like with any software that works with laser scans, the quality of the laser scan data absolutely impacts what we're able to do from a software and an algorithm standpoint. That being said, we've had very good results with things like ductwork, duct with duct wrap, black sprinkler pipe, because fortunately the errors that the scanner gets usually are relatively statistically spread out, and so you end up with a relatively good idea of where that piece of geometry actually is installed. You just, you probably wouldn't want to go to a subcontractor if it said it was 1.01 inches out and yell at them if it's a big shiny object, because the data obviously is not 0.01 inch accurate.
Got it. Two more questions. Can you adjust tolerances by level and by element?
Yes. So the answer is yes. Generally speaking, we would recommend that you treat any bulk group of objects that you want to have a different tolerance as a different analysis. So, for Tim's example, you might run level 1 as one analysis, level 2 as the next analysis, and level 3 as another analysis if you had a different tolerance, because steel, as it goes up, you may need to make adjustments. The other thing to do is to break up those scans and have localized control. So if you have control on level 3 to tie into, you don't need to have a lower tolerance for level 3 than you do on level 1, because that control is going to move with the building as it blows around in the breeze and expands and contracts and all the other physics things that those of us in the reality capture industry have to put up with.
Okay, and the last question is kind of an interesting strategic question for both of you guys. So what do you do about full disclosure to the owner customer about the Verity data?
Tim, you want to take a first stab at that since you actually still work for a general contractor?
I don't know all the long amount of lingo that we've got in our laser scan risk management department. I have not digested that entire document, so I really can't. I don't know. I know that there are errors, perceived errors, not errors, but perceived tolerances in the laser scan themselves. I mean, the one we use is 2 millimeters. So as you're registering everything together, there's that inherent error. So, you know, they just need to know that this is, you know, based on data in the field, that, you know, as long as everything's registered together right, it's more accurate than you're going to get with a tape measure a lot of times. But no, I'd have to refer back to my risk management department and try to figure out. We do have a document circulating around it with laser scanning being like coming on board so quickly, so fast now. The lawyers are getting involved, and we basically have disclosure agreements that we have people sign if they are going to use it to lay out against and whatnot. But the details of that, not quite sure. So I'm sorry not to be able to answer that one. I can't answer one of the other questions that I saw for computer, like what do you need to run Verity? I know that I upgraded my SSD hard drive and to a 1 terabyte at the minimum to process a lot of the stuff. And once I did that, my processing time on just point clouds in general went from like 8 hours down to 2 hours on some of the bigger jobs I had. So definitely an SSD hard drive is key for processing. I'm sure Verity would like that as well.
Yeah. And so
didn't mean to put you on the spot with that question, Tim, but I mean, there's no doubt that Verity and laser scanning, you know, have the potential to be great risk mitigation tools. Kelly, would you agree?
Yeah, and I mean, my answer to the question would be that as a general contractor who's not, you know, if you're not doing self-perform and installing the work yourself, you know, your obligation is to the owner to make sure that that work goes in to industry tolerances and within reason. And so it's really, you know, I think a matter of what is quote unquote within reason. Does that align up to the tolerance that are specified for that job? And then how do you navigate that with your subcontractor, knowing that you're going to be, you know, you have some obligation to disclose this information to your owner as a general contractor, and then setting expectations right with the owner. I mean, control on job sites is something that's going to be plus or minus ½ inch to an inch. And so if the control is that far off, then the geometry is, you know, all the tolerances and specification manuals are based off the control, not based off the absolute physical location in the universe if we had perfect measuring tools. So, you know, it's a layered and complex thing, and navigating that with clients can be challenging. But I also think it's a good mitigation tool, just because when these things go in the wrong place, you know, if anything goes wrong down the road, particularly with structure, you don't want to be the one that's on the hook. And if you can document everything that is, you know, marginally off and get that signed off on by an engineer, get that signed off on by the project team, by the owner, you know, that's a much better legal footing to be on than somebody trying to blame you for a piece of steel that's, you know, 4 inches to the east or to the west that nobody ever knew about until something happened.
And I would state that the models that we get from engineers and architects too, also those need to be correct in what they want to see installed in the field as well. Like, you know, after we incorporate our subcontractors' coordination models too, that it can only analyze against what it's fed in the model. So the more accurate the model is, the better the results are. So it's kind of a twofold thing between the laser scan and the actual design.
Yeah.
Okay, that is all we have time for. We've got a ton of questions that we weren't able to answer, but we will answer those via email to the asker over the next couple days. And we will also be at SPAR and at BIM Forum, and Kelly and Tim and a few other folks are speaking at both SPAR and BIM Forum. So if you've got questions, come to our booth or buttonhole Kelly or Tim at SPAR or Kelly at BIM Forum and ask away, and definitely come see us at both of those. And as I said, if you're interested in a trial subscription of Verity, please get in touch with our sales team, and thank you very much. We appreciate it.
Thank you.